Well students, topic of the video is calculus of finite difference. In this video we discuss delta and nabla, and using difference table we can find value of delta, any power of delta of f, and any power of nabla and f. So here x and fx 1 3 5 7 9 1 9 25 49 and 81. Now you see that there is 5 values of x, so there is highest of nabla delta is delta to the power 4. Delta to the power 4 fx. Now you see that delta fx, difference of 9 and 1 is equals to 8, or 9 minus 1, second minus first one. Difference of 25 minus 9, this one is 16. Difference of 49 minus 24, this one is 24. 49 minus 25, this one is 24. And difference 81 minus 49, 50 32. And difference of these two, 16 minus 8 is 8. Difference of these two, 24 minus 16 is equals to 8. Subtraction of 32 minus 24, this one is 8. Now see that this one is x naught, this one is x1, this one is x2, this one is x3, this one is x4. Similarly, this one is y naught, this one is y1, this one is y2, this one is y3, and this one is y4. Now this one is delta fx naught, that is delta f of 1. This one is delta f of 3. This one is delta f of 5. This one is delta f of 7. And from the lower part, this 32 is equals to nabla f9. This 24 equals to nabla f7. This 16 equals to nabla f5. This 8 equals to nabla f3. And this one is delta square f1. This one is delta square f3. This one is delta square f5. And this one is nabla square f9. This one is nabla square f7. This one is nabla square f5. And the rest of the terms equals to 0, because 8 minus 8 is 0, 8 minus 0, and the rest of the terms become 0. So which value it can't get from the difference table, those values are 0. As for example, nabla delta square f7. This one is delta square f7, this one is delta square f1, delta square f3, delta square f5. There is no delta square f7, so delta square f7 is equals to 0. Or nabla square f5, this one is nabla square f9, this one is nabla square f7, this one is nabla square f5. So nabla square f5 is equals to 8. If we have to find delta cube f3, there is no delta cube value, so delta cube f3 is 0. If we have to find nabla cube f7, there is no value of nabla cube f7, those these values are 0. Next sum is estimate the missing term in the following. Here x equals 1, 2, 3, 4, 5, 6, 7, and y equals 2, 4, 8, 32, 64, 128. So we have to find the f4. Now you see that there is only 6 values of fx or y, where y equal to fx. So if you see that if ax square bx plus c, this is a polynomial function of degree 2, there is 3 unknown. So to find these 3 unknown, we have to know 3 conditions, but here is 6 conditions. So polynomial fx is a polynomial of degree 5. And now see that from the in the previous sum we see that there is 4 value. If there is 4 value, then we can find up to del cube, and del to the power 4 fx obvious 0. If there is 5 values of fx, or 5 known values of fx, then del to the power 5 obvious 0, because up to we have to find maximum del to the power 4. If there is n values, then we can find up to n del to the n minus 1, and del n is obvious equals to 0. So from this sum here, del 6 fx is obvious equals to 0, because there is 6 values of fx, and there is a formula del of fx equals to f of x plus h minus fx, and that one is e of fx minus fx, and that one is e minus 1 fx. So del equivalent to e minus 1. This is shifting difference. So similarly, del 6 fx is equals to e minus 1 whole to the power 6 fx is equals to 0. Then binomial theorem formula we get 6c0 e to the power 6 minus 6c1 e to the power 5 plus 6c2 e to the power 4 minus 6c3 e to the power 3 plus 6c4 e to the power 2 minus 6c5 e plus 6c6 within bracket fx. This one is equal to 0. So 6c0 is 1, is e to the power 6, 6c1 is c e to the power 5, 6c2 is 6 into 5 by 2, that is 15 e to the power 4, 6c3 is 6 into 5 into 4 by 6, so 20. E cube plus 6c4 equals to 6c2 by the formula ncr equals to n minus r. So 6c4 equals 6c2, and value of 6c2 is 15, so there is 15 e square, and 65 is 6 minus 6 e, and 66 is 1 into fx is equal to 0. Now e to the power 6 fx, there is a formula e to the power n fx is equals to f of x plus nh. So e to the power 6 fx is equals to f of x plus 6h minus 6 e to the power 5 fx is f of x plus 5h plus 15 e to the power 4 fx is f of x plus 4h minus 20 e cube f of x plus 3h plus 15 e square plus 15 e square fx f of x plus 2h plus fx minus 6 e fx is f of x plus h plus fx is equals to 0. Now they will see that there is difference between two values of x is 1. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1, 7 minus 6 is 1. So use in the place of h equals to 1. So this one becomes f of x plus 6 minus 6 f of x plus 5 plus 15 f of x plus 4 minus 20 f of x plus 3 plus 15 f of x plus 2 minus 6 f of x plus 1 plus fx is equals to 0. Now we put first value of x. There is first value of x is 1, so we use x equal to 1, or we put x equal to 1. So f of 1 plus 6 is f7 minus 6 f of 1 plus 5 is 6 plus 15 f of 5 minus 20 f of 4 plus 15 f of 3 minus 6 f2 plus f1 is equals to 0. Now you see that f7 is equals to 128, f6 equals to 64, f5 equals to 32, f4 is unknown, f3 is 8, f2 is 4, and f1 is 2. Now there is only one unknown, this one is f4, and from the remaining part we can find f4. Next sum is estimate the missing term in the following. Here is 0, 1, 2, 3, 4, 5, and in the place of y there is 0. No, there is no f of 1, f of 2 is 6, f of 3 is 13, there is no f4, and f of 5 is 25. So we have to find f of 1 and f of 4. Now you see that there is 4 values of fx. So polynomial is degree of polynomial is 3 because there is 4 unknown. So del 4 fx is equals to 0 by the previous sum. So del 4 means e minus 1 whole to the power 4 fx equal to 0. So 4c0 e to the power 4 minus 4c1 e to the power 3 plus 4c2 e square minus 4c3 e plus 4c4 is 1 is 0. So 4c0 is 1 e to the power 4 fx, e to the power 4 fx is f of x plus 4h. 4c1 is 4, e cube of fx is f of x plus 3h. 4c2 is 4 is a 12 by 2, that is 6. E square of fx is f of x plus 2h. 4c3 is 4, e of fx is f of x plus h, and there is fx. Now you see that here is also 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, and 5 minus 4 is 1. So h equals to 4. We put h equals to 1. So x plus 4 minus 4 of x plus 3 plus 6 f of x plus 2 minus 4 f of x plus 1 plus f of x is equals to 0. Then we put x equal to 0. Then f4 minus 4f3 plus 6f2 minus 4f1 plus f0 is equals to 0. So f4 is unknown, f3 is 13, f2 is 6, f1 is unknown, f0 is 0. So by this calculation, f4 minus 4 f1 is equals to 6 into 6 36, 6 into 36, 13 4 is 52. So minus 52 plus 36 is equals to minus 16. There is minus plus 16. This is equation 1. Now again we put in this equation x equal to 1. For two unknown we have to put first two values. For one unknown we have to put only first value. In the previous one we put only the first value. But here is two unknown, so we put first and second both. In this equation we put x equal to 1. We get f of 1 plus 4 f5 minus f4 plus 6 f3 minus 4 f2 plus f1 is equals to 0. So by putting f5 is 25, f4 is unknown, f3 is 13, f2 is 6 and f1 is 1. f1 is equals to 0. So minus 4f4 in the right hand 4f4 minus f1 is equals to 25 into 6 into 3, 6 into 3 78, 24 minus 25 minus 24 is 1, 13 6 is 78, 78 plus 1 is 79. This is equation 2. Now you solve equation 1 and equation 2. Four f4 minus f1 is equals to 79. We multiply first equation by 4. So 4f4 minus 16f1 is equals to 16 into 4, 64. By subtracting 15f1 is equals to 5, 6, 15. So f of 1 is 1. By putting f of 1 in equation 1, we get f of 4 minus 4f1 minus 4 into 1 is equals to 16. So f of 4 equals to 16 plus 4 equal to 20. This one is f4, this one is f1. Next sum is find fx and hence find f of 4.5 from the table. Here x is 0, 2, 4, 6, 8. fx is minus 1, 13, 43, 89, 151. So there is 5 values of x, so we can find maximum delta 4. So del fx equals to second minus first, this one is 14, this one 43 minus 13, this one is 30, 89 minus 43, this is 6 and 4, 151 minus 89, this one is 51 and 11, this one is 62, and this one is del square fx, second minus first, 30 minus 14 is 16, 46 minus is 16, and 62 minus 46 is also 16, and there is those terms are same, so del cube and del 4 fx are 0. So here fx equal to f of x naught plus nh. Here x naught is 0, so f of 0 plus nh, so f of nh, and this one is, or we can write this term like this using shifting operator. This one is e of n fx naught. Now e is equals to 1 plus delta whole to the power n fx naught. Now x naught is equals to x equals to, here is x equal to x naught plus nh, and x naught is 0, so 0 plus nh, and h equals to 2, so here n into 2, and the n equal to 2x, so n equal to x by 2, so 1 plus delta whole to the power x by 2 fx naught. Here x naught is 0, so f of 0. And 1 plus delta x by 2 is equals to, this one is 1 plus x by 2 into delta plus x by 2 into x by 2 minus 1 by 2 factorial, this one is 2 delta square, and rest of the term is not needed because del cube and del 4 and minimum and other terms is equals to 0, so plus dot dot f of 0, and by multiply this one is f0, this one is x by 2 del f naught, this one is x by 2 into 2 x by 4, and within a bracket x minus 2 by 2 del square f0, and f0 is minus 1 plus x by 2 into del f0 is 14, and this one is x into x minus 2 by 8 into del square f0 is 16, by calculation 8, by cancellation 8, 16, 8, and this one is 7, so this one becomes minus 1 plus 7x plus 8x square minus 16x is equals to 8x square minus 11x minus 1. and this one is fx. And now we have to find f of 4.5. so f of 4.5 is equals to 8 into 4.5 square minus 11 into 4.5 minus 1. Then we can find value of f of 4.5. In the next video on this topic, we discuss few more sums on numerical analysis or calculus of finite difference.